Hi folks, this is College Algebra Quiz 3. Number 1, we're asked to sketch a pair of graphs. Sketch the graph of y equals absolute value x, include at least 3 key points. So absolute value, we should remember that's a V pattern. And the 3 key points we can use, negative 1, 1, 0, 0, and 1, 1. And remember, the way we get these is we plug these x's in, evaluate the function to get out the y. So the absolute value of negative 1 is 1, the absolute value of 0 is 0, the absolute value of 1 is 1. And so we plot these 3 points, and then you have to know that this is connected in a V shape. And so that's 1a. 1b, we're asked to sketch the graph of this function, y equals absolute value of x plus 2, using the graph you started in a. So we look at where this plus 2 is happening. This plus 2 is happening outside the absolute values. Since it's happening outside the absolute values, that's going to affect the y values. We're going to be adding 2 to all the y values we had before. So the point negative 1, 1, if I add 2 to the y value, that's negative 1, 3. The point 0, 0 gets moved to 0, 2. I'm adding 2 to the y value. And the point 1, 1, that goes to the point 1, 3. Go ahead and plot these values. Negative 1, 1, 2, 3, 0, 2, 1, 3. And it's going to have the same basic shape. It's going to have that nice V shape that we had before. Okay, so it's the same graph. We've just moved it up 2 because we're adding 2 outside the function. And that'll do it for number 1. Number 2, we're asked to sketch the graph of y equals square root x, and once again to include our 3 key points. So for the square root, x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. When x is 4, the square root of 4 is 2. And so 0, 0, 1, 1. And this is connected in a half a parabola shape. So there's our basic graph y equals square root x. For part B, we're asked to sketch the graph of this function using the graph in A. And notice we're adding 2, but we're adding 2 inside the function. We're adding 2 inside the square root. So since we're adding inside the function, that's going to affect the x's. And remember, when we're adding inside the function, we're going to be subtracting 2 from the x's. So the point 0, 0, I subtract 2 from the x value. That gets me to negative 2, 0. The point 1, 1, I subtract 2, negative 1, 1. 4, 2, I subtract 2, gives me 2, 2. I'm going to graph these points. Negative 2, 0. Negative 1, 1. And 2, 2. And I connect these with that half a parabola shape. And so we've taken this graph and shifted it to the left 2. And that'll do it for number 2. Okay, here's the bonus for this quiz. I normally don't talk about the bonuses, but this is an important skill I want you to have. And so let's talk about how this is done correctly. We're asked to solve for x, right, or answer an interval notation. We have a nonlinear inequality. What most students do, and I warn against it, but it happens anyway, is they want to multiply both sides of the equation, or excuse me, the inequality by x minus 2. And the trouble is, we don't know where the x has been. So x minus 2, maybe it's positive, maybe it's negative. Why does that matter? Well, we've got ourselves an inequality here. If we multiply both sides of this inequality by a positive number, then nothing happens. It remains a less than or equal to. But if this is a negative, then we would have to reverse the inequality. And since we don't know what case we're in, and we don't want to go about breaking it into those cases, what we do is we get everything on one side, we get 0 on the other, and we make our sign diagram. So the first step in this is to take x over x minus 2, subtract 3, and get it less than or equal to 0. The next step is to find our critical values. To find our critical values, it's most convenient to get this in terms of one fraction, which means we need to get a common denominator. In this case, the common denominator is x minus 2. And so we have x minus 3 times the quantity x minus 2 is less than or equal to 0. And now we simplify this. Depending on how you were brought up in algebra, we're going to have x minus 3x, so it's minus 2x plus 6. So we now get our critical values. Critical values are any place the numerator is 0, any place the denominator is 0. And once again, we're looking for places where we could change from being positive to negative. So critical values, we set the numerator equal to 0. We get x equals 3 out of that. Places where the denominator is 0, we get x equals 2 out of that. So what we do is we display these then on our real number line. So here's 2 and here's 3. And then we check around it. Favorite number less than 2. Favorite number between 2 and 3. Favorite number bigger than 3. We take each of these test values, we stuff it into this, and see if it's positive or negative. So if I plug 0 in, on the top I get a positive, on the bottom I get a negative, which means I'm going to get a negative overall. Plug in 2.5, get a positive on the top, get a positive on the bottom, that gives me a positive. Plug in 11/7, get a negative on the top, positive on the bottom, I get a negative overall. I look at my inequality, I want to know where it's less than or equal to 0. It's less than 0 on these intervals. That's where I have my negatives. That's where it's less than 0. Where is it equal to 0? Well, it's going to be equal to 0 at potentially the critical values. If I plug in x equals 3, I get a 0 over 1 that's equal to 0. So I'm going to keep him. If I plug in x equals 2, on the top I get a 2, on the bottom I get 0, and that's undefined. So I'm going to leave out the 2. And so my final answer is going to be, in interval notation, parenthesis negative infinity to 2 parenthesis union bracket 3 to infinity. And that'll do it for the bonus, and that'll do it for quiz 3.